call linear inequalities. We've done a lot of graphing in this class, so we're going to do inequalities, which we haven't done yet. All right, so to begin with, on the first page, you're going to just do something real simple to kind of get you the hang of what's meant by what I'm going to show in this section. So first of all, you've already seen this before. You know how to graph a line, hopefully. Okay, that's y-intercept -1, slope 2. The question is this point on the line? Well, there's two ways to do it. One way is to graph and see if it's on the line. Okay, so I'm going to show you this. You don't need to do this on your calculator, but I want to just go ahead and show this to you. I'm going to put in 2x minus 1. You could graph that by hand. I'm just going to do that in a standard window. Okay, well, if you traced it 3, if you type trace 3, well, 5 would come out, so it's on the line. Now, that's one way to do it. That's how you do it with technology. How would you do this without technology? How would you know it's on the line? You'd plug it in, exactly, okay? Because what you do is x is 3, and then y is 5. If it works, if it checks, then it's a solution. So you would just have 5 equals 2 times 3 minus 1. So that's 5 equals 6 minus 1. So that would be yes, that point's on the line. Okay, that's what a line is it's a picture of all the solutions of the equation. That equation has an infinite number of solutions, but they all fall on that line. That's the idea. So that's the way we're going to do these. This next one, you would just plug in 1 for x and 5 for y. So you would have 5 equals -3 times 1 plus 10. That's 5 equals -3 plus 10. So what happens on that? It's not on the line, okay? So it doesn't check, so that would be not on the line. Okay, that's not a solution, all right? So that's how you do that. We've talked about that before, but a lot of times students don't understand that's what a graph is it's a picture of every solution of that equation. That's what it is, okay? Now we're going to do inequalities because this is what we're going to learn here today is how to graph inequalities like this. So we're going to do the same thing. Just plug 3 in for x, plug 5 in for y. Now you have an inequality, so it's going to be 5 less than or equal to 2 times 3 plus 1. So that's 5 less than or equal to 6 plus 1. So that's 5 less than or equal to 7. Is that true or false? Yeah, that's true. That's true. So the answer to this would be yes. And we'll kind of learn about the graphing here in just a minute. So you're just seeing if it's true or false on an inequality, all right? So the next one we'll do the same way. You want to plug the 1 in for x, and you want to plug the 3 in for y. Just work it out. So that would be 3 greater than 2 times 1 plus 1. So that's 3 greater than 3. True or false? That's false. Okay. So since it's false, we would say no, that point is not a solution of that inequality. Okay. All right. Let's do this. This almost looks like the same problem. I just want to point something out. Let's plug a 1 in here and a 3 in there. So now you would have 3 greater than or equal to 2 times 1 plus 1. So now you got 3 greater than or equal to 3. Is that true or false? Yeah, what's the difference between the two problems? One of them was greater than or equal to, the other one wasn't. So that's true. So that would be a solution like that then, okay? Now the purpose of this, once we learn how to graph, this will give you the way to check and see if you're getting your solution correct, okay? So I want you to just do these 3 down at the bottom here yourself real quick. Then we'll move on and start learning how to do the graphs. Most of this section is about graphing an inequality. So either they're going to work or they're not going to work. So what happened on number 1? Was that yes or no? That's yes. Okay, you plug it in, you would have 0 plus 6 equals 6. So that's a yes. Okay, that means that point's on that line. Okay, the next one, is that true or false? Okay, it looks like if you plug it in, you would end up having 9 less than or equal to negative 2 times negative 3 plus 3. So that's 9 less than or equal to 6 plus 3. So 9 less than or equal to 9 is true. Okay, so that would be a yes. That point would be in the solution because they're equal. Okay, the next one, if you plugged in, you would have negative 5 greater than 3 times 3 minus 12. So you would end up with negative 5 greater than negative 3. Is that true or false? Students a lot of times mess up on these negatives. On a number line, negative 5 is smaller than negative 3 because it's to the left of it. So that one's false, so that's a no. Okay? Is everybody solid with what you just did? Okay, now that's how you check and see if a point is a solution either of an equation or of an inequality. Okay, now let's go to the next page and we'll start putting together the graphing on here. All right, so I took these pictures out of the book. What we're going to do is we're going to be solving inequalities. So, like if you have a vertical line, it divides it into 2 parts. You have the right part and you have the left part. If you have a line that slants, it divides it into an upper part and a lower part, like that. All right, so you're always, when you have a line, you're going to divide that into 2 different parts of the plane. The plane just means the whole entire flat surface you're graphing on that goes on infinitely, so it'll divide it up like that. Okay, now this is what's kind of important, so let me go through these things right here. I'm going to kind of zoom in on this first one right here. What I'm doing on this problem is I'm graphing the solution set of y greater than x minus 2. All right, that's your y-intercept. So notice on this one I put a dot there, right? Okay, the slope is equal to 1 over 1. So notice I went rise 1 over 1 like that. So that would be the graph of y equals x minus 2. So this would give you all 4 situations there are. Notice I used a dashed line. The reason I use the dashed line is because it's greater than. It doesn't have an equal to bar on it. So that means that every point on that line would not be a solution. It wouldn't check in the solution, okay, because it's greater than. If it was greater than or equal to, then you would use a solid line because it is a solution. Okay, this is the same thing. I've graphed the same thing. Greater than or equal to, again, that means that you're above. Greater than, it just means everything above is where that solution is. And then the difference between these two is that's a solid line there, and then that's dashed like that. Okay? Does that make sense to you? So when we have an inequality, you're shading part of the plane. You're telling me where the solutions are. All the solutions are above if it's greater than. And then these are less than. Okay, less than just means you're below. Again, this is a dashed line, and then the one next to that is solid like that. All right, so that's how that goes, and we're going to learn basically how to get things graphed in this particular section then. All right, so let's fill out a couple of things then. All right, so just kind of what I was trying to show you. When did I say you use a dashed boundary line? Yeah, just less than or just greater than, right? No equal to, so it would be less than or greater than. Okay, when would you use solid? Less than or equal to, greater than or equal to, right? It's got to have the equal to bar on it like that. Okay, and then it's very logical. If it's greater than, where do you shade? You shade above. Okay, or you could shade to the right. Okay, if it was a vertical line, you would shade to the right. We'll look at that in just a minute. If it's less than, you shade, I should say, below or to the left like that. Okay, so greater than's above, less than's below. Real simple, right? Okay, so let's go to this next page here, and we're going to put together some graphs. That's mostly what you're going to do in this section. So we'll do several examples of this. First of all, this one, what is the slope on this problem? 2/3. What's the y-intercept? -2. I'm going to write that as the point 0, -2. So what you want to do is you want to go ahead and graph this. We've been doing this all semester. You've already learned how to do this. So you're going to start at -2, then you're going to go up to right 3 to get the next point, up to right 3, like that. Now, am I going to use a solid or a dashed border line on this, boundary line? Dash. So go ahead and just dash it in. That's real important. You got to know the difference between the two, like that. Okay, so that's how that line would go. Now, where do you shade on this one, above or below? Below, because it's less than. That less than is saying that all the points are below, so you just kind of shade, just take your pencil or whatever and just kind of show that you're shading in that region there. Okay, and that's the idea. Okay, now here's what the meaning of this problem is, and I want you to just pay attention to this. I'm going to pick a point right here. I'm just randomly picking a point. That point is the point 3, -3. If I plugged that point in, what do you think would happen if I plugged this point into this inequality? Would it work or not work? What do you think? It'd work, absolutely. If you plug in -3 for y, you would have that. Then you'd have 2/3 times 3 minus 2. See, what you'd end up getting is you'd have -3 less than 0. So the point is, every point here works. How about all the other stuff? They don't work. So that's what it is. I'm just highlighting and showing where everything works. Okay? Let me ask this question. Okay, how about this point right here? That's the point 3, 0. Do you think that would check if I plugged it in? What do you think? Yes or no? No. How come? Well, it's on the line, and it's a less than. It's not equal to. If it was less than or equal to, then it would check, but it doesn't. So this point right here, that won't check. Okay, like that. So that's just kind of the concept of this that you want to know, is everywhere in the shading region works. Everything that isn't does not work. That's the idea. Okay? All right, next problem. Slope is -2. Y-intercept is 0, 3. Okay, what do you do with the slope if it's a whole number? Put it over 1, and then you would go down to right 1 on this one. So rise over run. So go ahead and get it graphed. You would start by doing y-intercept at 3, then you would go down to right 1, down to right 1, and do I do solid or dashed on this one? I do solid. Good. Okay. Do I go shade above or below on this one? Above. Okay, it's greater than, so I'm going to go above. Okay, so I just kind of shade in that region like that. That's it. Okay, so everything in the yellow checks, everything that's not in the yellow doesn't check, but everything on the line does check. Okay, so it's kind of like a bracket and parentheses. Bracket includes, parentheses doesn't include. This is the same way. It's just the way that we represent that. Okay, all right, is everybody with me okay? Hey, you've already learned how to graph lines. You're just now putting the inequality together. Okay, this one, what you want to do first of all, this one is you want to solve this equation for y. Okay, it's not solved for y like the other one, so we're going to go ahead and just move the x to the other side. So we're going to have 4y greater than -2x plus 8. Then we can divide both sides by 4. Like that, so that would give y greater than -2 over 4 reduces to -1/2. 8 over 4 is 2. So you want to start the problem by solving it for y if it's not, and then you just do the same thing. So now what's the slope? -1/2. Y-intercept is 2. Okay, like that. Okay, and then what you want to go through and do is just kind of start putting this together the same way, but you'd have to solve for y first, so you would have a y-intercept of 2. Slope would tell you to go down 1, right 2. Like that. You would use a dashed boundary. It's hard to draw a line on this. And do I shade above or below? I shade above. Good, okay, because you do have a greater than problem like that. So the only thing that's different on that one is be sure that you solve for y. Okay? All right, the next one. This is the other thing that can happen. So you have y minus 4 less than or equal to 0. you would want to get y isolated, so you'd add 4 to both sides, and then that would give y less than or equal to 4. Okay? Now, we've done this. Students a lot of times forget this. How do you graph y equals 4? That's horizontal, right? It goes through y equals 4. So this one's going to go like this. You're going to go through 4, and you're going to do, again, a solid boundary line because of the equal to bar like that. Okay? What is the slope of that line? 0. Does it have a y-intercept? Does it cross the y-axis? Yeah, it crosses at 4, so that would be 0, 4. And then how do you think you shade this one? Below, good, okay? So you just shade below like that. See, sometimes you can have vertical and horizontal lines, so it just means below on this one, same thing, okay? All right, so go ahead and I'm going to have you do the next 4 on the next page. Just want to make sure you're okay with what's going on here. Now, we don't do a whole lot in this section. It's a pretty short section. So go ahead and let's work on those for a little bit. And then I'm going to show you how to do these on the graphing calculator. I mean, you have to know how to program the calculator to do this, so it won't do this for you. You have to know how to put it in. And I'll show you on how to do that as soon as you're done with these. There's a couple of them that I want to, particularly that third one, I want to kind of see if people catch something on it. I think that one you didn't count your slope out. You'd have to go, that's why I set to 0, but you'd have to go down 4. Okay. Okay. Shade, now that one would be solid. As an equal to, so it's a solid boundary line, no dash. That one will have dashes. Then you want to shade below. Less than means more. Sure you shade. Oh, you did, yeah. That's below. It's less than, so just kind of, that's good enough on the end. Just the right place and the right time. That's those last two. I think you guys are doing pretty good on the first two. On this first one, I'm going to go ahead and work them out and finish up where you're at. The slope on this one is -4/5. The y-intercept's 0. I think everybody caught that. So you just have the point 0, 0. So this one, you'd put a dot at the y-intercept, and then you'd have to go down 4, right 5 to get your next point. So I'm going to go down 4, right 5. Then you would have a solid boundary line like that, and then it's less than, so you just show that you're shading below like that. Okay, so that's what you should have come up with on that one. Okay. The next one, you have a slope of 3. You have a y-intercept of -5. If you have a slope of 3, you want to go up 3 and to the right 1. Okay. So I'm going to start at my y-intercept of 5, then go up 1, 2, 3, and over 1. And then this one you should put a dashed line on, like this. And then this one was a less than problem, so you should shade below like that. So I think everybody seemed to me like they were getting the first one okay. I think a few of you may have missed that intercept on that first one, okay? Now, here's the one I didn't really check. I just want to see how many people did this right. I bet some people weren't paying attention on this one. So let's find out, okay? I may be wrong. So what do you have to do? You have to solve for y. So the first thing that you want to do is move the x to the other side. So you get -2y greater than -x plus 4. Then what do you have to do? You have to divide by -2. Did you catch anything on that? If you divide an inequality by a negative, what do you have to do? Did you guys flip it? If you didn't, you messed up. Your answer is probably backwards. So you have to pay attention to stuff like that. So that's y less than, and that's 1/2 x minus 2. See, the two negatives divide out, leaving you 1/2 x, and 4 over -2 is -2. So actually in this problem, the slope's a half, and the y-intercept's -2, but since we changed the signs to less than, it's going to be below. I'm not sure if everybody caught that or not, but if you shaded the wrong place, you just need to correct that then. Okay, so this one would be y-intercept -2, up 1 over 2. This one would have a dashed boundary line, and then you would be shading below because we had to change the sign when we solve for y. So be sure that you're careful about that when it shows up, okay? All right? All right, the next one. This is the other one sometimes students do wrong on. How do you graph x equals -3? That's a vertical line. It's vertical. It goes through x. A lot of times students get that backwards. If x is -3, then it's always got to go through only the x-axis. So this one you would draw a solid boundary line like that, and since it's greater than, where would you shade? You'd shade to the right, okay, like that. So that's how that goes. You want to be solid on what the difference between vertical and horizontal lines are. What is the slope of a vertical line? That's undefined. How about the y-intercept? Does that graph ever cross the y-axis? No, so it'd be none. Okay, that's what you'd have. Sometimes students don't catch those vertical and horizontal lines. If it's x equals a number, it's vertical going through x. If it's y equals a number, it's horizontal going through y. Okay, like that. Okay?
Shaded is the possibility to be right.
Yeah, if it's a vertical, you're either going to go left or right. If it's horizontal, it's going to be either up or down. Okay.
The shaded portion of it, I'm just saying, is the part that.
Say that again?
The shaded portion is things that it can be.
Yeah. Yeah, I mean, it would be all the way right, just right at the borderline and everything to the right. Okay. Okay, now let's see. Next page, I'm going to do just a couple of these. We'll just do these together, I guess, on this. So I'm giving you this. I'm just doing it backwards. This is a good activity for students to do. If you look at this problem A, look at my line. What does it look like the y-intercept is? Okay, it looks like it's 0. You have a y-intercept of 0. How about the slope? Just count that out in your head. What does it look like? Looks like up 2 over 1, like that. So that slope would be 2. Okay, now, so what we know that we have y equals mx plus b. All right, so we have y and then we have 2x. The plus 0 can be left off. Okay, what would I put there? Less than, greater than, or what? What do you think? It's below, so what would it be? Less than. Would it be less than or equal to? It'd be less than because of the dashed. Okay, so you could just write the solution as y less than 2x like that. Okay, so that's how that goes. Okay, the second one, it's vertical. So what's the slope of a vertical line? That one's undefined. It doesn't have a y-intercept. All right, so how would you name that line? If it's vertical, what do you say? X equals -2, right? All right, so we have X and we have -2. Well, what would it be? Greater than, less than, or what? Because we're shaded to the right. And it would be greater than or equal to because you have the solid boundary line like that. Okay, that's the idea. Everybody with me there? I'm just reversing what I just taught you, that's all. Okay, all right. Go ahead and I'll just give you a minute to see if you can process the next two on there, okay? And we just got a few more things to finish up here. All right, so on this part C, the y-intercept's 4. What is the slope? Okay, so it looks like you're going down 1, right 1. So it'd be -1 over 1, it'd be -1. Okay, so the answer you should have got was y, and would it be what, greater than or what? It'd be great, yeah, like greater than, okay. Then it would be -1x plus 4. Okay, that's what you should have got. Okay, we get that? Okay. All right, the next one, the slope is 0 because it's horizontal. The y-intercept looks like it's 3. So what did you put on this one? Okay, good. Y less than 3. Okay, so remember, if it's a horizontal line, it's y equals a number. And it would be open, so it's less than, since you're shading below like that. Okay, that's the idea. So that's the main thing in this section, is this is going to prepare us for what we do in the next two sections, and we'll get pretty heavy into applications a little bit more next week. All right, next thing is just kind of preparing you for word problems. When you're putting together things like this, you want to understand how the language works and how these things turn into the inequality symbols. Okay, this one says you have fewer than 20 candidates. So I'm just going to use a variable for candidate C. So if it says fewer than 20 candidates, do you think that would be less than, or do you think it would be less than or equal to? That's less than. Fewer means strictly fewer. 19.9, that's what fewer means, okay? The next one says you should consume no more than 2,500 calories. So I'm going to say C is calories. How do you think you would write that? No more than 2,500. Okay, less than or equal to. Good. Okay, you can't be bigger, but you can be equal to. That's what that means. Okay. This one says practice your instrument no less than 8 days. So I'm going to say P for practice. What do you think on that? No less than 8. Okay. Okay, greater than or equal to 8. Okay, that's good. Okay, interest is at least 2.5. What do you think there? Okay, greater than or equal to. It means 2.5 or bigger. Okay, so it would be that. Okay, monthly income is over 4,500. I'll use I for income. What do you think? Yeah, it got to be strictly greater than. So when you're doing word problems, you got to make sure that you understand the meaning of that and do the translation. I pulled this off the internet that you can refer to if you need to, but it's helpful if you understand those things and can put those together okay. All right. Okay, I'm going to finish up class here with this last example, and want to just give one example on this. So I'm going to read this. It says a candidate has budgeted $10,000 to spend on radio and television advertising. It says the radio ads cost $200 and the TV ads cost $800 for the 30-second spot. Now remember, the question always tells you the unknowns. Okay, and that's always a good place to start on a word problem, is what are the unknowns. So it says how many radio and how many television spots can be purchased. That means there's two unknowns. So let's start by just writing down X1 is the number let's say that's radio spots. We'll just say radio spots for your advertising. Okay, and then X2, we're going to say that that's equal to the number of television, I'll just abbreviate that as TV spots like that. Okay, those are your two unknowns. Those are numbers that you have there. Now, what do those things add up to? Which number? Because that's what this is saying is you've budgeted this here. So what that's adding up to is that's going to be a grand total of 10,000. Okay, all right. So you have $10,000 budgeted on this. Then each individual one costs $200 for the radio and then $800 for that. So what you would have on this then is you would have X1 and then you would have X2 like this, but this would be $200 for X1 and then it would be $800 for X2, and then that's going to add up to $10,000. Okay, so it's just that. All right, now the thing on this is it says this. It says how many radio and television spots can the candidate purchase without exceeding the budget? So if without exceeding the budget, would that be less than, greater than, or what? Okay, without exceeding would mean smaller, right? So that would end up being less than or equal to like that. Okay, so it can't exceed it. It can be equal to it, but just can't exceed it. Okay, now we're going to do this one on the calculator. So what I want to have you do on this is we're going to solve this equation for X2, because I want to teach you how to do this on the calculator to finish up. So we're going to move this over here. So you'd have 800X2 less than or equal to negative 200X1 plus 10,000. And then I can divide everything by 800. And we can just use decimals on this one, and I'm fine if we just do that. So we would end up having X2 is less than or equal to, and this would be like negative 0.25. You could do that on your calculator, X1. And then the next one, if I do that on the calculator, if I just do 10,000 and divide that by 800, let's see, I get on that 12.5. So that would actually be what we're going to graph on the calculator, because that's a linear inequality, all right? So get your calculator out. I do want to show you how to set this shading part up, because it will be important for things we do in the next section. So what you do is you just go to y equals, and now we're using x1 and x2, so this is really, you know, y, and that's really x. So just put in negative 0.25 times x, and then put in plus 12.5 like this. And I'm going to have you adjust your window a little bit, because that 12.5 is a y-intercept, and you want that y to go up at least as high as 12.5. So for a window, I'm going to have you do this. Just go negative 10 to 10, and then for y, let's do negative 20 to 20. Like that, okay? That'll be a pretty good way, I think, to scale that, and you can leave the scale at 1 if you want to, like that. So you know that's going to give a line that's sloping downward, and so it's going to go like that. Now here's how you do the less than, okay? Now you have to program it, so that's going to shade below, right? So here's what you do. You go back to y equals, and you want to move your cursor all the way to the left so it's blinking on that little piece right there, okay? When it's blinking on there, press enter. Now go down to the middle thing where it says line. So take your down arrow key and get it blinking on this thing, okay? Now use your left and right key. Just go left, and what it does is it changes it to different things. Like there's a dashed line. There's another dashed line. That's like a ball. Keep going, and eventually you'll, I'm on the wrong thing here, crap. Okay, let me get, you can adjust the color too if you want to, okay? So I'm going to go down here, and you look until you see this thing right here. That has a triangle that's showing that you're shading below. So then you press enter like that. Once you find it, just press enter, and then now go back and graph and see what it does. Whoa, isn't that cool? Man, that's sweet, isn't it? Yeah, okay, so you can do that, okay? You can do, now what it'll help for is what we're going to do next class is we're going to learn how to do systems of inequalities. So you got to kind of find a common shading area, so it is helpful for that thing, okay? All right, so that'll wrap us up for today.